So while we're waiting, two notes here. So number one, you guys, three notes. You have the Wi-Fi here. If you don't already, just connect to the Wi-Fi. Point number two is we do have the hashtag WebRTCBCN. If you have comments, if you have feedback, if you have anything, please hashtag it, Twitter, and we're checking it. So please let the world know what we're talking about here, please. And there's one other point. Just to, as you guys already know, we're grouping these guys together, but by no means does this mean they're talking about the same topic. We're trying to add different perspective to everything here, so different perspective is good, and different topics are good. So please, keep the questions coming, keep the different perspective coming. All right? And with that, I don't think John, yours first. All right. So with that, let's turn it over to Oscar.
Thank you. Okay, so thank you everyone for being here. My name is Oscar Divora, and I am Media Cloud Engineering Lead in Tokbox. And today I wanted to talk about a little bit WebRTC. So I just put this title, WebRTC Anytime, Anywhere, Any App, from small to big multi-party audiences, because basically I wanted to have a little review on what is necessary for actually getting WebRTC out there in the street and having it working. And once you do that, the use cases that keep coming and that appear, which probably are something that was not possible really before in an open manner, also come with a number of requirements on architecture, on how you have to stream media, etc. So basically, I wanted to make a review of different use cases and then see how does it map into different requirements on architecture for streaming media, and see basically what you think about that. So first of all, and before starting, just for me to gather, I already asked this last time. I would like to know how many of you actually are programming or are developing applications or use cases for WebRTC. Okay. And from those that didn't raise the hand, how many of you are familiar with the technology? So you already had some introduction before. Okay, thank you. So basically, at least a good chunk of you will know that what WebRTC is not actually, and basically what it actually provides WebRTC. WebRTC is a set of enablers, is a technology that actually brings the possibility to business to enable blending of video communications in a seamless manner and in a very flexible way with a number of use cases that it's certainly not constrained, and it's open to anything that a product manager can think of or come out for a business case, right? So we already had before some glance of what WebRTC APIs offer. And we know that basically what we have is basically a set of APIs that are embedded into the browser and that give the capacity to the browser to actually be able to stream media and communicate in a peer-to-peer manner, if you like, with other engines in the network, either browser or whatever you can invent. However, what comes with the browser is basically the API, the set of protocols that actually the specification of protocols by the ETF that allow the browser to talk with something else, and then, if you like, another part of this puzzle of WebRTC is the open source that actually Google made available, so that it's available to anyone, so that anyone can see and look how this is made, how this can work, and even use it for integration, right? So with these three things, basically, we could do some very basic applications, but if we actually want to build some large-scale product that actually uses video communications, that is, many businesses basically what they need is to actually deploy a sort of ecosystem of applications that implement a given use case, that depending on the platform, they may have a slightly different use case than in the other platform, but altogether it's an experience and it gives access to a given business model or to a given application, right? So basically, the business will want to actually implement something here that is their application that can be anything, can be banking, can be e-health, can be sports, can be support, tutoring, anything. We'll see some examples afterwards. But basically what WebRTC gives out of the box from the browser, let's say, would allow you to implement some very basic form of it based on the website. And still, depending on whether you are using one browser or another browser, you would have differences in how they behave or in how they operate a little bit, because maybe we are still in this period that things are not completely. So that you would also need to take care of that. So if you really want to actually be able to deploy an experience across many platforms and beyond just the peer-to-peer between two browsers, for example, you actually, at least you would need to have plugins to be able to work with Internet Explorer and Safari maybe. You would need to have some decent SDKs so that you can cover mobile implementations and that it is interoperable with the website, with the web parts. In mobile right now, there is no integration. Let's say there's no available integration de facto within the operating systems themselves. Maybe one day there will be. I hope there is at some point, but currently not, and certainly nothing else either on the desktop. Yes, you can go there and maybe get the software from Google, but good luck. I mean, the amount of work you still have ahead if you really want to make a cross-platform product with it. Then you probably, if you need to set up sessions and rooms maybe, and add users to each session, you probably need some sort of server-side SDKs that interact with a given core server that actually orchestrates all this stuff, basically allowing you to connect to a given system, allowing you to set up connections and create sessions and add users to those. And below that, once you have succeeded connecting to a given system, then you should be able to actually establish these connections, these peer connections from a given browser to another browser or to another mobile, or even if you want multi-party, which is actually something that is increasingly the more and more needed based on use cases, you would need to have some media server. So media server that is actually able to give you scalable multi-party that is not too costly for operation, that maybe handles the quality a little bit for you. As we were saying before, there is no quality of service. And pardon, but hardly there will be. Basically, one of the biggest points or one of the weakest points of a connection basically is the access point. Normally, once you are into the network, things are not that bad. But when you have to get to an access point with your laptop or with your mobile, sometimes at home I get just mad. For example, you know, our office is in San Francisco, and sometimes we have like late night meetings. And I live in one of these big buildings in the city, and I have not yet bought myself a 5G router. It just gets crazy at night sometimes to actually have some decent communication sometimes, and I have to get closer to the router because I have too many neighbors. You may want to do archiving, or we'll talk later. Maybe you just want to broadcast. I don't know what we can do with that, but we can see options afterwards. At the same time, you may want to send signals. Maybe you want to be able to, your use case may want to send simple events or signals between different endpoints. And even you may want to know how much are you using all your system. You can do this all yourself, or you can also go and work with a video as a service vendor. for that. So basically, all this is what you at least need to put together if you really want to have like a cross-platform big service based on WebRTC. So with that, where are use cases bringing us? Right before, someone said that most of the cases are one-to-one. We could say that we are seeing a trend in the market where that is actually changing, because maybe the money may be lying somewhere else. And for instance, one thing also is how many sessions there may be in one-on-one, but then also how many minutes there may be in one-on-one compared to the other use cases. But still, they are very important. And we have use cases that are very relevant. You all know probably this use case. It's basically mobile telepresence from iPad to iPad. You can control the robot on the distance. This is a pure P2P service. In the platform, you may be needing some turn servers in order to overcome some NATs or some firewalls, but that's it. Same here, the tutoring use case, right? So normally you will have maybe two people. Here I have the colleagues of Czech that basically have built this product where they provide one-to-one tutoring on their application. Or even more professional cases like for mobile, Fluke, for example, provide these tools to their engineers so that when they go and try to fix something on the road, they can ask somewhere more expensive engineer that's sitting in some office. Okay, why should I cut the red or the blue? I mean, how should I do that, right? This is helpful. But we are quickly going to something more. We are starting to call something one-to-one plus. Why one-to-one plus? Because basically most of the time is one-to-one, but sometimes, like for the case of Royal Bank of Scotland, that basically they needed some solution for that. They sometimes will have someone that really talks with you usually, and that actually handles your case on an online banking system. But eventually, if you need to invest on some stocks, they will bring an expert that's for that. And if you want to buy some bonds, they will bring the expert for that, right? And basically, this calls for the system to have some flexibility. You need to be able to bring people in, people out, and it's not a P2P anymore like what one could think of just between two bros, right? So you need something on the network that actually allows for that flexibility. Or for example, Calgary Scientific, right? Same case, but on the professional side, we have doctors that basically have this tool that allows them to access common resources and profiles from patients. And whenever they need it, they will call some other specialists or some additional experts into their work time so that they can also give their comment about what's going on with that patient, right? Going up, field to field, I mean, the multi-party communication that we are used to at work, like or Hangouts or whatever you would like to call it, would be that. But then there are things more elaborate, like for example, Roll20 is a company that basically develops and puts a system for collaborative gaming, and basically it's based on allowing people to actually co-play within the same team building, having kind of being able to chat around the context and actually have a good time thanks to the multi-party video communication. Certainly this could be done in P2P, but we can comment after the further things. And then the many-to-many. Here you can start forgetting about P2P ever. There are also a lot of emerging cases, like for example, Minerva project, where what we have here is like a university classroom, a lot of people inside the room. Maybe you have one or two people on stage, the professor, maybe someone else that's actually speaking, and then you will have like maybe 30 or 40 people, or let's say 20, whatever big number of people assisting here and interactively participating in the classroom. Just that eventually one people will go up into the stage or go down, and at the same time you'll have to handle the quality so that it doesn't kill your CPU, it doesn't kill your network. And this has to all happen under the covers, right? So how do we solve the scalability and control for that quality? So, well, as I said, you need to have some solution. You need to send all the video from somewhere to somewhere. One can think, okay, I could do mesh. Maybe for 3 people could be okay, but we already know, everyone knows, I guess, that this has its limitations. Then we could have the more traditional transcoded version of MCU or the selective forwarding unit that has some advantages. Let's see, just very in detail, what's the good thing of the MCU that basically allows a client to send video and to receive a composed video of all the others. It's cheaper in bandwidth, up and down. It's traditional. Every single branch will be rate controlled individually. So it's good, actually, because since we don't have quality of service and we want to have the best possible quality for everyone, every single branch will have the best possible quality for itself. And then it may have some media processing that is good to have, for example, if you want to compose archivings, or even if you want to start something for broadcasting. Problem, it's expensive. You need to have here a lot of processing, a lot of encoding, a lot of, sorry, 2 minutes already? Oh. And then we have the SFU that basically allows to send one stream up and then it receives many down. What's the good thing of this? The good thing of this is that it's very flexible, and basically it allows you to have to accommodate many use cases that are very flexible. One bad thing is that in very basic SFUs, the publisher will stream at the worst capabilities of every one of the subscribers, except if you use simulcast, for example, where the publisher is able to send many different qualities, and depending on the subscriber, you will send one different quality for each one of the subscribers that from the bundle that is sent from the publisher. More. Do we have more? We can have more use cases. One to large many. These are appearing right now. So basically we have sports providers that actually provide lessons of sports to large crowds using some broadcast scenario. And even some more interesting thing, live sales. Why would you like to do some online live action, I would say, to 20 people or to 100 people in a room when you could do it to 10,000 people? Certainly, we cannot afford delay here if it's an action, right? It has to be interactive. So there will be some limitations. Or, okay, webinars. They say crowdcast webinars that don't suck. Basically, webinars that allow you to interact properly and not just with some 1 minute delay, for example. And few to many. So use cases that are appearing basically for the consumer. People basically create their show, and some of them are able to basically, with some companies, are able to actually get a lot of audience suddenly, and this is available to them through the right use of architecture on the internet. Or even for content production. So we have Fox Sports that they create broadcasts where they actually have like maybe an after sports comment with an expert, football player, and someone from the audience. All the audience receives this, but at the same time, one of the audience will be promoted eventually to actually join the crowd here and be able to discuss directly with the star. You cannot afford delay or too much delay in here as well. So how do you do that? Well, introducing new facts into the architecture in order to enable the use case. We can have the classical SFU for very low delay, cost-efficient communication, and then have a server that's able to compose the video that you need to send, generate the HLS at the same time, and then generate a HTTPS-friendly distribution of video, much like the ones you use for video on demand. This has certainly delay. But as we move forward and we work further on technology, this is the possible trend we are taking, where actually, if you use the right technology, like combining the use of SFU with simulcast or scalable video, you can actually be able to, one single box, here I have concatenated two boxes, but already with one single box, for example, you could have a very large amount of subscribers or endpoints connected to a given publisher, receiving a stable amount of quality. Let's see, for example, here the example. This is basically from production data. Let's imagine that this is subscribers per publisher. I'm finishing, this last one. And this is the bit rate, so kind of think the quality. Then if you don't have simulcast in a SFU environment where basically all the rate control is performed by the publisher, you'll have that the more subscribers you have, the more probable to have a bad, one guy with a bad connection. So in the end, all converge to bad quality. If you use simulcast, it's a completely different story. And beyond that, a lot of further evolution that we can do. Basically, question would be actually for you now. So it's, what is your use case? And what do you think is the architecture you need?
Sorry to rush you off. Out of respect to the others, I just wanted to get Guy on stage here. Guy?
Thank you very much indeed. And thanks to Dialogic for having invited me here. Is this microphone working as well, in case I... It is, yes. Excellent. Okay, I should point out before I begin that I'm not here representing Gintel, I'm here representing my own company. And I'll explain why that's significant shortly. First, I have to get to grips with this device, which I never do. Do we have anything? Yes, hurrah. Okay, so in 2011, we attended quite a number of conferences, and the topic of WebRTC, and in particular HTML5, kept coming up repeatedly. And we realized that this was a very interesting and emerging topic about which few people knew anything apart from a tightly knit community of quite nerdy technical folk who were busy pursuing standards in the organizations. But yet it seemed a really exciting area. So what we decided to do was to create a report, originally thinking about mobile applications and the possibility of using HTML5 as a way to bypass the then prevalent, well, indeed still prevalent application store model. However, in continuing to dig into this, we realized that HTML5 itself opened up an enormous amount of new possibilities, many of which we've just heard about thanks to the great synopsis from Tokbox. But what we wanted to do specifically was to think about the opportunities that the combination of HTML5 and WebRTC enabled for operators to perhaps assert control over some of their assets and think about how they might extend services beyond their traditional network boundaries in much the same way as what we perhaps describe today as the OTT players had been doing so successfully. So we didn't want to prejudge our conclusions, but we looked at a lot of literature, we talked to a number of people, we talked about licensing and so on and so forth, and we came up with a number of conclusions which we then published in the report and tried to sell. We sold a few, but sadly not quite as many as I would have liked. But anyway, there we are. It was a really worthwhile exercise because we found that there were clear opportunities, much as the GSMA later found a couple of years after this, for what we would describe as a quasi-enabled remote access to telephony services which would be federated by the privacy and security that operators can bring. There are a whole bunch of other use cases which have subsequently emerged, and in particular, much of the attention focused on WebRTC shifted in another slightly different direction to which I shall turn in a moment. But essentially we saw operators as being providers of what they might define as the equivalent of OTT applications, which is all very good. Here's an extract for the report, which you can if anyone actually wants it, do get in touch. I'm sure we can find some ways to distribute it. But it was really interesting to see how there were ways in which even the smallest operator could do something quite useful and quite exciting and indeed innovative. We were fortunate enough that one of our customers translated this into Japanese, and they distributed it quite widely within their organization, that's NTT, and indeed many of the ideas they then had for WebRTC applications seem to have been at least, I won't say inspired, but they used a lot of this framework that we proposed to help guide their thinking in their laboratories, because they're very clever people, and they had a very, very large research team which was looking at the possibilities for enabling better human interaction through WebRTC, as we saw in the GSMA's list there. Okay, a lot of the early focus, as I say, switched to online shopping, and the idea that if someone fills up a shopping cart in a website, they may not actually click through to complete the purchase. So this is called, in the industry, online transaction abandonment. And indeed, if you look, you can see a chart through time showing that abandonment rates increased, which is not a good thing if you're a retailer. What you want to do is to get as many people to buy things as you can. So if you can decrease that rate even marginally, it can have a huge impact on sales. That was an exciting area. Oracle did some very fine work in this area during that period, and we're articulating a number of good solutions around it. Okay, so what's happened since? Let's bring things up to date a little bit. WebRTC is basically now accepted and demanded. It's very interesting hearing about standards evolution, and I'm awfully glad that people are taking care of those things. People who are developing need those kinds of stuff, and know you can never have enough standards. That's absolutely fantastic. However, the term WebRTC is, I think, going to disappear from many of the conversations that people are going to have, particularly in the enterprise world. They don't care what a WebRTC is or how many standards there are behind it. They care that it does something quite cool and opens up new possibilities for them either to sell something or to get or to interact in other ways with customers. By the way, our entire consultancy is almost exclusively focused on services that are to do with B2B. We have nothing to do with consumer focus. So we're interested in people who pay, not people who expect free stuff. And I strongly recommend that many of you focus on those too. Okay, so almost every vendor is developing a story around WebRTC, calling it what it won't be WebRTC in a little while. It's the implication. We want to be able to do this. That's the driving force. And we understand that there's some new way in which we can do that. I think there are two key areas beyond those original click-to-call. That's what it was, click-to-call. There used to be methods to do this with pint and spirits, which were pretty rubbishy early versions of click-to-call from IP sessions. But now we have something really quite substantial and substantive, in fact, which is going to be useful. So we have two key areas. I'm going to talk about both cases, and then I'll finish because I don't want to take up any more time. First one is WebRTC as a way to extend unified communications capabilities via browser sessions so that you are truly device independent. You might not be browser independent because not everyone supports it, as we've already seen. On the other hand, what you get is the potential, oh, someone's stolen my phone, which is a sadly all too frequent occurrence at Mobile World Congress. Haha, now I can access my unified communication capabilities because I can log in using my MSISDN and some other form of identity in case someone steals my phone number too, and now I can quite happily use the same services that I had. This is really good. It doesn't sound very interesting and very sexy. It's a de facto requirement that we're going to see on almost every RFP for a unified communication solution from an operator. It's just table stakes. Okay, so we can move from there. Nomadicity. Some of you may have heard of that term. I like it a lot. Brand extension through portals, essentially. Cloud phone, seamless, multi-device, multi-screen experience, simple upgrade. It's free. You can't charge for this, but what you can do is you can add it to an existing high-value bundle that business subscribers consume. And of course, it gives you the roaming case, which was the original OTT motivation that I discussed, but it gives you device independence. BYOD, this is kind of important here. And of course, it's convenient. People like it. Okay, last case, affordable contact centers. The previous case, by the way, was from my friends at Gintel, who are here. But this one is from a German company called JTEL. And what they've done, this has been endorsed by Google, and it's a really cool thing. They made a press release about it earlier this week. It's a call center. There's a PBX ACD combination in the cloud. Very nice. Then there's some connectivity to that call center. But the agents do not have nice, shiny accessories. What they have is a Chromebook and a browser and a headset, and that is it. Okay? It is rapid deployment. It is absolutely disruptive in terms of breaking down the cost for populating a contact center. And this has just been launched this week at Call Center World, which is happening in Berlin at the same time as Mobile World Congress. Okay, so there's two main impacts. You have the contact center, click to dial we've talked about. boosting conversion, yeah, okay. Really interesting, the impact on infrastructure for call center providers and people who wish to deploy architecture quickly and cheaply. It really could be a game changer there. Okay, that's another way of looking at it, because in the contact center world, we have to talk about omni-channel these days. It's very much the voguish term, but it means any form of communication, inbound and outbound, should be part of the consideration. Okay, so conclusion. WebRTC is a label, a useful label. It means a great deal to many of the people here who are actively developing things, but as we turn to the wider market, looking at the bigger picture, people won't care what, just as they don't care what 3G is. But what is important are the outcomes, as we've seen from a number of presenters here. It's going to be, I think, the place where you make money, unified communications and contact centers, absolutely fantastic. Hugely disruptive deployment models are emerging, and some great services. And like I say, it's a market requirement for UC solutions. So that's us. That's it. Thank you very much.
Hi everyone, I'm Jean Doruel. I'm one of the co-founders of Telestax. I would like to thank everyone for coming today to the WebRTC Meetup and for Dialogic to invite us to speak today. We are the company that provide, for some of you know, the open source RESCOM communication platform. Some of you knew this platform known as MobiSense. We recently rebranded MobiSense into RESCOM. We'll show what we provide in the open source platform and what we have learned with the mobile WebRTC SDK that we are providing in the open source, and some of the lessons learned into deploying those WebRTC SDK. So this is basically the technology stack that we have, that we built in the open source for the past 12 years. We started off mainly as a pure telecommunication play. So mainly in the operators network, IMS and legacy network. And we have been moving into making it as easy as possible for web developers and mobile native application developers to basically integrate communication as a feature into their application. So we built upon our expertise in the telecommunication area to try to make it easy. So we provide REST APIs for web developers to integrate communication. So it can be voice, it can be video, it can be SMS, it can be USSD for some of you that know about USSD. Geolocation as well. We talked about QoS. I will come back to that a little bit later, but this is something that we want to try to tackle as well in the open source. And as part of that, we moved beyond the only server-side play that we have into the client side as well, to help mobile native application developer and web application developer to integrate communication. So we started WebRTC SDK on the web, on iOS and on Android. And we also do client applications, so example on how you can use those SDK and customize them to build your own applications. So our SDK are using SIP as a signaling protocol, or SIP over WebSocket. As the previous panel mentioned, there was no signaling defined in the WebRTC spec, which is good because it leaves open to everyone the choice. So people might prefer SIP, people might prefer SMPP, people prefer HTTP. Some people don't care, they just want to integrate communication. We've chosen SIP because we interoperate with existing operators network, and for us it was easier to actually deploy SIP in terms of time to market as well, and it's already scalable as a protocol, so we use that for the SDK as well. And for the media part, we use WebRTC. So what are the lessons that we learn on the mobile side? So We talked a lot about QoS. This is what we learned as well, is not only about QoS, but how we can improve the quality of the experience of the user. And some of the QoS goes into that. And we are working with partners called My Mobile Coverage to include in the open source SDK quality of service. So what this means is there is always network updates. We are nomad, as Guy was mentioning, in terms of we are moving from places to places. So sometimes you may have a bad Wi-Fi connection, or you're moving from 3G to 4G or 4G to 3G, and your connection is degrading. You may want QoS from the network, but you can never guarantee that you will have a very good connection. And what is important is to let the application know about some certain events or some certain quality metrics from the network that they can use and build visual indicator into the application to notify the user that the quality of the connection is degrading, maybe because you're moving, maybe you're in a car and the quality is degrading. So you can give insight to the application on, okay, the quality of the connection is degrading, maybe I should stop the video call and do audio call only, and then upgrade back to video when I'm on 4G or when I'm on Wi-Fi. This is kind of use cases that we try to enable into the mobile SDK as well, and into the application. So I'll keep moving on that. Some of things that are important as well is connectivity prioritization. So if you're on 3G and you're paying for the data connection, you may not want to actually stay on the data connection if you have a good Wi-Fi connection. So you don't want to pay a lot of money if you have a good Wi-Fi connection available for free, by example. So we may want to give insight based on those QoS, based on those metrics from the network or from the devices, and insight into the application saying, okay, you're on the data connection, but we also have a Wi-Fi connection that seems to have good bandwidth. Maybe you can hand over to that and avoid some kind of bill shock. Some of the other limitation when you're in a mobile environment is, as the person from Tokbox mentioned, there is multiple ways where you can do video conferencing. But when you're in a mobile environment, there is other concern in terms of the device you're running on may not have a very good battery life, or you may be at the end of the battery. So you may want to take into consideration some of the aspect of mobile. Or if you're on the data connection or on a low bandwidth connection, you may not want to go with the full mesh network because you'll need to stream end time the stream to all the participants. So you may want rather to go with solutions that may be more scalable for these use cases of the mobile, such as an MCU, by example, where you can actually stream only one connection, and you keep on the mobile side the user experience and the battery life much better. So that's one of the lesson that we learn as well. There is quite a diversity in terms of fragmentation in the Android or other part of the market. It's not only about the screen. So as an application developer, it's important to take into consideration all of those screen resolution, but it's also about the hardware diversity. Some may have GPU enabled, they may have codec optimization. So some of them can potentially save you battery life and have a better experience. So it's important to take those into consideration as well. Not all devices are built equal, and this may have an impact on how you build your application and how the end user experience is on your application running on those devices. So it's very important to test. There is quite a lot of diversity there. There is a number of solutions that can help you test on multiple of those devices. So again, one of the lessons learned is there is some concern to take into action when you build application on WebRTC and on the mobile specifically. So one thing that we mentioned was NAT traversal from the previous panel, where you using eyes that was defined in the WebRTC spec to be able to open pinhole in the NAT so that you can keep communicating with other peers. You're basically gathering candidates behind the NAT to advertise a public IP and port so that others can actually contact you. But this may take time, and the specification evolve into something called to improve the setup time, because it can really take up to 10 seconds, by example, to gather all the candidates, which lead to poor user experience. So it's very important to try to reduce the call setup time as much as possible, especially in use cases like emergency scenarios. So trickle eyes basically allows you to gather candidates and send them as they are discovered, and not to have to wait for all the candidates to be gathered. So this is things to take into consideration as well when you're on the mobile side. So we use sync SIP, so it's kind of specific to SIP in that case. So if you use a different signaling protocol, this may not have impact on you, or if you're just building the application and not on the implementation level. But with SIP, especially on Android, we've been using in our protocol stack a stack called GenSIP, which is actually what is actually bundled in all Android SIP phones since version 2.3. But the stack never evolved, and the API didn't evolve either. The issue is that when the stack was included in the Android from Google, they didn't change the package name, so we had to build another stack, changing the package name so that there would not be any a conflict of namespace. There is some operator also that blocks SIP traffic when, for example, Verizon is blocking SIP traffic at some point. This has an impact also on your deployment. If you're using SIP, some version of Android don't allow the SIP traffic on TCP for port 5060 for long packets. So you need to default, which is good, to using SIP over TLS so that the signaling is secured. But there is a number of deployments and use cases on the mobile that you find out only when you test on the real network. So same thing, so WebRTC in terms of security is coming with boring SSL as an implementation. Some of the SIP stack out there for iOS, by example, come with a different version of the SSL implementation. So you may have impact in terms of when you build that as a mobile SDK to actually combine everything together. So as I mentioned, we are fully open source. So if you want to contribute, same thing with WebRTC, which is open source by Google and by other vendors. All of our stack is open source. So if you want to actually join and help and grow this, we are always welcoming volunteers. We actually have a number of companies that are volunteering to add new things into the mobile SDK. One is Quobis and quality of experience into the SDK on the mobile side and also on the server side. Geolocation is another. Co-browsing and remote control for some of you that know the service called Amazon Mayday, which I'll cover a little bit later, to cover some of the services, file sharing, trickle-eye support. So there is a number of things where we need help and where we would welcome any contribution. And that can lead to hiring as well. So feel free to come and help. Everything is on GitHub. So if you go to github.com/rescom, you'll find all the project there. So feel free if you want to hack on some innovative technology to come join us, or to reach out to me, or to someone at the company, or even in the community. We are welcoming anyone. I wanted to cover some of the WebRTC use cases quickly. So some of the use cases that we faced was telemedicine, by example. So we have a company called HealthSense that's building devices that monitor and track for aging people, their life condition, and are able to alert the call center if some of these devices is triggering a notification because the person is in a bad state of health. It's more kind of an IoT use case that is enabled by WebRTC as well. In this case, they're using the data channel to send back the information to the server to trigger the notification that an agent should be sent on site. We had a hacker also that hacked an application on Apple Watch to also monitor the blood pressure and do the similar kind of things in one of the recent hackathons called TADHack, where people are building application for the communication. Real-time translation, so something like what Skype is doing, where you basically transmit the audio and the video to a server, and you're able to, in real time, enable real-time translation. This is one of the use cases that's popular on the mobile side as well. Remote workers, so this was already presented, and since I'm running out of time, I'll skip that one. Facial recognition, it's pretty important in terms of security, not only also for contact centers, like Guy was mentioning, where you can do emotion analysis and you can give that feedback into the agents for seeing what their speech is having as an impact onto their customers, so you can get a lot more insight on that as well. You can have kind of identity 2.0 with facial recognition to actually trigger the opening up of the device, this kind of use cases. Customer experience, so Amazon Mayday, which is using the WebRTC as well, where they ship their device, the Amazon, the Kindle Fire, and if you have any issue with the device, you can actually click on the button and get connected to one of the agents in the call center, and the agent can actually remotely indicate and co-browse with you or take remote control of the device to actually help out. So it's kind of improving the customer experience, and this is actually an application that that one of our partners, Span System, is building, and that they will open source into GitHub as well, based on our mobile SDKs. Something more social, a company called Be My Eyes, which are using WebRTC to actually connect impaired people with other persons that can help them see. It's for the blind people. Home office security, so kind of remote control of monitoring of your house, and if there is any detection of something unusual, that can actually stream directly what's happening in your house, and you can even talk to the people in your house that are trying to steal you and say, oh, I just called the police. Especially if you want the Amazon Echo, you can even maybe have their reply to you. So this is some of the use cases as well that can be enabled by WebRTC, and that's pretty much it. Thank you.
Appreciate it.
All right, so one more round of applause for all three, Oscar, Guy, and John. So one question I get asked a lot are, what are the use cases for WebRTC? And I think we just got a bunch there. So I'm going to open it up to you guys. Questions?
Sorry, from the first speaker, of the architectures that you presented, you didn't have, did you ever take into account a torrent-based peer-to-peer system where you could do one-to-multi client connections? Like something like a torrent, you know, so one person sees.
Yeah, right. That's an architecture. Has pros and cons. One of them is that probably the endpoints that basically take care of your traffic are out of your control. So you don't know what is their bandwidth, and you cannot do much about them.
Yeah, but you don't need servers.
You don't need servers, but it all depends if you want to warranty like having like 2 megabits per second quality that you are being sending. I think it has some limitations concerning the amount of control that you have on the quality, on the final quality that the final receivers will receive. Also, then if you need to actually change the topologies of the call that you are having, for example, it's not just one person to many, maybe one person, but the person that's broadcasting may change during the course of the call or the use case. It depends on the interaction as well. So you may need to change the topologies on the real time as well, and that can be a hassle.
More questions? All right.
So for Guy, what's your gauge on where the enterprises are at right now? Are they? I hear a lot of the use case is cool, but we're not ready to jump in yet. And they kind of give me a list of considerations.
Well,
what's your experience with that? And what do you say to them?
Obviously, we only gain experience through our customers. We don't work directly with enterprises as such. But what I can tell you is we've been working extensively with our clients and helping them understand that this is an emerging case, this is what's happening, blah, 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 blah. 2 or 3 years ago, my friends from Germany went off to a big WebRTC conference in America. It's in Florida, I'm sure you go. And it was fantastic. They came back terribly excited about what's going on. Went to Germany, poor, no one's heard of it. Okay, that is now changing. In markets which are quite well self-contained, let's say, and very strong in themselves, there is certainly momentum happening. Tech companies are starting to release solutions. And like I said, perhaps somewhat provocatively, no one actually cares whether it's WebRTC. They care about the cool things that it enables. It's an access to services, in other words. And there is absolutely traction happening at an enterprise level, even in a market that I might characterize, and I hope no one will be offended by this, as perhaps a more conservative. I mean, there's still loads of ISDN in Germany, so it doesn't evolve necessarily at the same pace as the UK or Scandinavia. That said, if we turn to the carrier world, absolutely, there have been significant questions. I don't think it's necessarily solidified into substantial deployments, apart from in some of the cases that we saw from our friends in the GSMA. But certainly the interest, the understanding and the awareness that this is something we absolutely have to include in our capabilities. There are some signs that we have early instances in Norway, and we will see them globally. But over the next, what we really also have to remember here is we are in the infancy. There are some early adoption pioneers. There were a lot of really nice use cases propounded by people, and we're going to start to see viral adoption of those as people, let's say I set up as a web shop. I love the yoga teacher example. That's absolutely fantastic. I can see lots of great uses for that. Perhaps not necessarily with yoga. Those kinds of entrepreneurial things will drive adoption. Absolutely. They won't know that they're doing it. They'll say, hey, there's a really nice way that I can sell my services through a portal online and bill people. And there's a large industry to which no one has referred, and that's nice and discreet, but that's going to spend a lot of money in this area and it's going to push adoption. So, absolutely. And we are seeing real cases too. And perhaps you have.
Yeah, I agree with that. Actually, it's more about making it a commodity for people to actually build services and application. And there is definitely a lot of traction. And if you go to one of the websites that was created by Victor, that was on the panel, WebRTC Hacks, you can actually see some of the big vendors, not necessarily operators, but we mentioned Amazon. It's a global scale, so they already use WebRTC. WhatsApp as well. So there is global deployment of WebRTC that we don't necessarily hear about, where people are saying it's still in its infancy or it's not finalized, but there is definitely global scale of deployments on that already. So yeah, I think it has it has good traction, and I think some of the use cases are not necessarily talked about enough. But in my opinion, it's more about making it a commodity and really as easy as possible for developers to jump on that and to integrate communication and really driving their business use case. So not spending a lot of time on the plumbing, but really spending a lot of time on the business value and creating new services.
I would just add, if I may, I think the advent of virtual reality-enabled headsets will particularly drive one aspect of it. I think that's going to be really fascinating. Gaming, you know, that side of thing, wonderful.
There is one on sex toys as well. It's more in the French market.
Because you're the only one. See, I discreetly avoided that, obliquely.
Other questions? I have one. John, you have a front row seat to seeing the evolution of the developers contributing on the open source community. What are you seeing as far as, is it hockey sticking as far as development goes? Are you seeing contributions of WebRTC flatline? Where are you at with?
So we are on the, I would say it depends on what you're speaking about. If you're speaking about the WebRTC implementation, we are not in the WebRTC implementation itself. So we are not on, I would say, on deep inside the media stack that's provided by the vendors. But on the application level, yeah, definitely. We see a hockey stick in terms of growth, in terms of contribution, in terms of people adopting the technology and building things with it. And I think what's really important is that we have been doing a number of hackathons across the world and with Dialogic as well, and sponsoring events called TADHack to actually bring developers to the communication world and trying to promote the communication aspect in terms of their business use case. And we have seen a lot of people with no knowledge whatsoever of telecommunication, of SIP, of RTP, of all the complexity that has been made available by the spec, which we implemented. I mean, we implemented a lot of those things in media server, in terms of NAT traversal, in terms of SIP, but WebRTC is taking the best of breed of all of that, and developers are completely shielded from that. So it makes it very easy for them to integrate that. And I think that's real power of this specification, is that it's easy and people don't even have to really think about the complexity of it, and they can just really focus on their application and service.
Questions?
Yeah, hi, this is for Oscar and John. Both of you recommend against mesh networks. You say because of battery usage, and I don't remember why Oscar said
Mesh networks, scalability.
scalability. But how bad are they really? Because I see like one useful application would be like in an emergency situation, you could improvise a network between computers of affected people in like a hurricane catastrophe or something like that.
Well, let's start with that. There may be applications in that line, that's it. But at least, for example, from the Tokbox point of view, currently our target of business basically lies on whatever use cases that can actually have the best, I would say, experience to set up their application. Before he was asking about the torrent thing, one thing that I could also have said that I can tell you now is that basically if you have like a ad hoc mesh that is not out of control, let's say, that it's not controlled freely, that will imply certainly a delay that will break interactivity probably, most likely, if you have like, if you try to search for good quality interactive return and back video, for example, and if you have to hope many places. The mesh that we talk about here mostly is, I think it's a bit more humble mesh. It's when you basically consider that one endpoint is going to talk with all the endpoints. And this has a huge issue in terms of CPU and bandwidth, because you have to send eventually one stream to every one of your destinations, and even as it's built now, for example, for browsers or for the usual stacks, you also encode many times the same thing. That could be fixed, but still you would be using much more bandwidth, and still rate control cannot be for the same one, so still you would need to, I'm just correcting myself, you would still need to encode many times, and that's a problem.
Yeah, I don't have much more to add. Pretty much Oscar covered it all, but in such, it depends on the use cases, but if you take a use case of, for example, disaster or emergency service, you may be in a situation where having a bad quality of service because you're using a mesh network is actually worse because you cannot even talk to people because the quality is so bad because you're streaming to so many persons that you cannot actually even hear each other, or you're in really bad quality of service, in which case the application is not even useful, so you're actually not able to help people, so it's even worse. But
So from your experience, which is the number of connections you'd say that is more or less decent?
I would say 3, 4. Beyond that, it starts to degrade pretty quickly.
For P2P.
Yeah.
We put the limit, we say always 3. If you're up to 3, have fun with 3 P2P, but no more than that.
We have time for one more. And if you guys don't ask, I will.
Hi again. We are building the future of technology, the future of the web. Our website around the world need this technology. Maybe Twitter need the technology to upgrade all tabs in the website to real-time communication. But we need make tools to deploy more easy for all developers. Not only talk about audio or video, we can talk another data. It's very important and very easy to integrate. And we can contribute by GitHub and other tools, but it's very important to integrate all website, all service, but this is the future of the web, the real-time communication. Thank you.
I think, Alexander, your comment is more of a mission statement for what people are achieving. And I don't think anyone would disagree with you. It's absolutely the future of contextual, real-time communication enabled over multiple endpoints to multiple devices and sorting it out, addressing social, business, as well as other use cases. So I think your words would be agreed with by everybody.
Guy is mentioning a very important point is that maybe I'm not sure if we covered really deeply is contextual communication, and I think contextual is very important. It's you can actually pass data along with the voice and video and enable a range of new use cases. So one of the, this remembered me, one of the hack we had at one of the events was from someone to actually be able to log in into LinkedIn or Facebook, his account, and actually browse on the website, and then just like Amazon made it, I'll be able to click on the button and get connected to an agent, and the application in the backend would get the data from the LinkedIn profile and be able to see, okay, this person is actually a Spanish speaker and is actually roaming in this location. So I'm going to bridge him to an agent that's close to his location to reduce the latency, as well as bridge him to a Spanish speaker right away. And if the connection drops, it's able to see, okay, this is the same person. If the agent is free, I'm going to bridge him to the same agent so that the person don't have to repeat 10 times to different agents what he just said. So contextual communication, thanks to WebRTC, is a very important use case in my opinion.
2 minutes. My last question for you guys, and then it'll be done. You all talked about great use cases. I want to know what excites you about the future. What use case do you see as being the use case that gets you most excited about WebRTC? Just maybe a vertical, an application, the killer app.
Left to right, or do you want to
Let's go. Let's start at the end and
Right
come
to
back
left.
this way. So.
Okay. Well, certainly, as we have said, WebRTC is all about contextualization, right? So all in all, it's the power of being able to blend on itself already media and data with the context that is the application, right? For me, it would be difficult to just pick one. But I would say that bringing expertise, experience, and highly skilled personnel at a given location can be really a game changer thing. One example, an application that I know, is basically when you're in an ambulance and you have someone that's having a stroke, you need a neurosurgeon there right at that moment to actually be able to assess what's going on. You don't have that. So if you can have this contextualization thanks to WebRTC and basically connect the necessary people, I think that e-health in this sense, in this line, is going to actually provide a good advance.
Okay, I'd love to say there was something cool, like, I don't know, an app that tells you the beer and gives you the nice rating in the bar and puts you through. But it's not. And there's stuff that will make money, and tons of money, which is great. I'm afraid for me, e-health absolutely is a key enabler. When you think about the possibility to enable a specialist who is located in London, Berlin, New York, Madrid, to engage in clinical practice in a remote site in a developing nation, and to have high resonance imagery enabled and shared, you know, the potential for that, for blending different capabilities and bringing in expertise and resources as you can. This is absolutely going to be huge, and I expect to see enormous investment in it from agencies that are NGOs and the like that are concerned with it. And I think that's a hugely promising area to bring expertise from the most successful medical and clinical experts into areas which they would not otherwise address. So that's perhaps sounds a bit dull, but that gets me quite excited.
For me, it's IoT in a sense that so far we've got cheap devices that don't necessarily have a lot of power. But what I see coming in the next few years and is commoditization of the hardware and be able to bring real-time communication into the IoT world as well. So there is this week there was an announcement in India of a company that is selling a smartphone for $5. So you can see that you can actually start to use those smartphone devices as IoT for not so expensive use cases where you get Wi-Fi, you get web camera, so you get everything ready to bring real-time communication in the IoT. And it actually bridge also to the health care in a sense that you start to have those kind of sensors where people were previously dependent. So when they had an issue in terms of aging, they had to go to the hospital or to a retirement house. And now they are able to stay at home and being monitored at home in their environment. So it's improving communication and life of people in general. That's pretty much.
And with that, one more round of applause for our panel here, and thank you very much. Thanks, guys. Thanks, Oscar. Thanks, Guy. Thanks, John. All right, we're about to wrap. We have just a few minutes left here. Want to give some stuff away? That's a lot. You can give everybody one. All right, so I guess we'll start with the big prize, and I don't. Thank you, guys. You can want to sit back. I don't want to keep you up here. Do we do? Oh, all right. Did anybody not get their ticket in?
No.
You want to? So what are the rules? Do we? Got it. Thank you. Got to be present to win? I think so, right? Hurry up. 30 seconds. You'll be our drawer, okay? You draw? You pick? All right, let me shake it. Hold on one second.
No.
All right. Any last takers? Mix them up a little more. All right. Pick one. Don't look at it yet. Okay, so before I pick it, I just want to, again, say thank you to all the sponsors. Oracle, Tokbox, wherever you went, Tokbox, Quobis, Dialogic, and UPF. So please visit the websites, check them out, retweet. All right.
Alexander Solos.
Solos? You asked the best question, sir. All right. We have a lot of good stuff over here. So we have books from Tokbox. We have T-shirts. We have all good stuff. Anybody wants it, come on down. Take it. And also, we have... We're just going to give them away. We'll just give them away. We got enough, yeah. I think so. Okay, all right. All right, we're going to draw some more. Boss.
Jesús Masteras.
You pick them, I'll bring them.
Jan Morvan. Guárdame los tickets que ya. Jordi Bailina. Denise Pailacho. Álvaro Cabanillas. Álvaro Cabanillas. Alberto Aspaclaud. Alberto de Apsaclaud. There. Amir Valetian. Amir? No. Amir Bacteri. Ah, he's live. You are you? Okay. André. André.
André Marcello.
André Marcello. Yeah. John Lantz. Guy Redmill. Luis Garavito. Hazael Macios. Yeah, no hay ninguna aquí. Libros. Just one here, please. This one here, the last one. Yeah.
Sorry. For those of you that did not get a book, well, plenty of T-shirts. T-shirt. Thank you again for everybody for spending their Tuesday night. Appreciate your time. Drinks 2 minutes away, more food, T-shirts if you don't fit after the food.